What if I told you that you could build not just one, but two complete, fully functional software applications from scratch, all in under an hour? Well, in today's explainer, we are doing exactly that. We're going to build a Python-based recipe parser API, along with a full meal planning app that automatically generates categorized shopping lists. And the secret to doing this so incredibly fast? We are leveraging AI every single step of the way.
So here is our recipe for today's build. First, we'll look at the 1-hour API promise. Then we'll tackle prepping the project setup, move right into scraping and AI parsing, wire up our REST API endpoints, and finally serve up the meal planner. It's a clear, logical path from absolute zero to a finished product.
Section 1. The 1-hour API promise, rethinking backend development.
Let's start with the big picture here, because we really need to challenge the old way of building applications. This whole thing perfectly illustrates the huge paradigm shift we're currently experiencing. Traditionally, most developers assume that building a robust, working API requires months of dedicated back-end experience. But honestly, with AI tools like Claude, you can shrink that months-long ordeal into an under 60-minute sprint. You don't even need prior experience with frameworks like Flask to pull this off. It's wild.
Section 2. Prepping the project setup, mise en place.
Okay, so to actually achieve this 1-hour speedrun, we really have to prep our workspace first. Think of this like our culinary mise en place. If your development environment is a messy afterthought, bugs are absolutely going to pile up. Things will break, and you'll spend all your time fixing instead of building. Now, what's really interesting about this exact prompt is how we explicitly tell the AI, hey, don't build any functionality yet. We're treating Claude like a trusted sous chef. We're just asking it to strictly handle all that tedious work of setting up folders, installing scraping libraries, API frameworks, and environment variable support. It keeps the whole environment totally clean and organized before we even write a single line of actual logic.
Once Claude finishes installing all those libraries, we have to establish our connection to the AI model itself. So we jump over to OpenAI, create a quick project, and generate an API key. Now this key is the essential bridge. Literally, without it, our web scraper wouldn't have anywhere to send the text it gathers. And crucially, we store this key safely in an env.example file. That just ensures our sensitive info is secure and never hard-coded into the app.
Moving on to Section 3. Scraping and AI parsing, gathering ingredients. So with our kitchen prepped and our OpenAI bridge established, it is time to actually teach our app how to read and understand incredibly messy web pages. And the crucial point here is how we break down this backend magic. It's a super clean 4-step flow. First, our web scraping function fetches the URL. Second, it extracts the raw HTML text, handling all those weird, totally varying layouts you see on random recipe blogs. Third, the AI takes that chaotic text and formats it. And finally, it returns beautifully clean, structured JSON data.
Now, this prompt, this is the absolute aha moment of the whole build. Trying to code custom manual scraping rules for every single recipe website on the internet is frankly impossible. They're all formatted so differently. Instead, we just instruct Claude to build an AI parser. We're letting the OpenAI model do all the heavy lifting of reading the unstructured text and interpreting those different writing styles for us.
And we tell the AI exactly what we want pulled from that mess. We ask for the ingredients as a neat list, instructions as clear steps, cooking times, servings, and the recipe title. But here is the brilliant part. The AI handles incomplete sections natively. So if some info is missing from the blog post, it just returns what is available without crashing or breaking our application.
Section 4. Building REST API endpoints, cooking the API.
Let's see how this actually builds into something other applications can use. It's time to turn our scraper and parser into a true REST API, a proper interface that can communicate over HTTP. So we prompt Claude to create a post endpoint that accepts our recipe URLs. We also have it throw in a health check endpoint just to confirm the server is running, core support, which simply ensures other web applications are allowed to securely talk to our API, and of course, proper error responses. Claude wires the scraper and parser right together inside this clean post route. But, why stop there? We can easily enhance this API to align with personal health goals. We can literally just prompt the AI to look for specific nutrition facts in the text.
We just tell Claude, hey, check the scraped text for calories, proteins, carbs, and fats. And here's a fantastic little design detail. We instruct the AI that if the recipe website doesn't include this data, just return null values. This ensures the API remains incredibly stable. It's never going to fail just because a blogger forgot to list the calories for their cookies.
All right, before we build the front end, we absolutely have to validate our work. We prompt Claude to create a really simple test script. By just running the script in the terminal, we launch the local server, feed it some sample URLs, and watch the parsed JSON results print out right in the console. It proves our scraper, our AI parser, our endpoints, and our nutrition extractor are all working together in perfect harmony.
Section 5. Serving the meal planner. Plating the final dish. So our back end is rock solid. Now it's time to shift gears to the front end and plate our final dish. We need a clean interface so users can actually interact with this powerful API we just built. And to build this quickly, we use Streamlit. Streamlit is amazing because it lets us build a full web interface with just a handful of lines of Python. We feed Claude this exact prompt, and almost instantly it sets up the page layout, the URL input field, the button to parse recipes, and a slick section to display the extracted ingredients and instructions.
But wait, right now the app only handles one recipe at a time. And let's be real, daily life requires full weeks of planning. So we prompt Claude to add meal planning features. Notice this seamless user journey we're building? You paste a URL, parse the data, assign that recipe to a specific day of the week over in a sidebar, and finally generate a combined shopping list grouped by category.
Let's actually see it in action with a live test. We drop in a link for an easy pecan pie. The API parses it perfectly, and we assign it to Monday. Next, we paste a link for a cheesy hash brown casserole and drop that on Wednesday. Finally, we parse some crispy air-fried chicken thighs and assign them to Friday. Boom! Just like that, our sidebar is fully populated with a real-world weekly meal plan.
And here is the ultimate payoff. With all those meals loaded up, we click the Generate Shopping List button. Instantly, the app combines all the ingredients from the pie, the casserole, and the chicken and neatly groups them by grocery category. What used to be a 15-minute manual chore of typing out a list is now an instant copy-paste button. Honestly, it feels like a total cheat code for meal prep.
So, we just went from zero to a fully working back-end API and a dynamic front-end meal planner in under an hour, completely transforming a really tedious weekly chore. It's incredible what we can build now. So I'm going to leave you with this final thought. Now that you know exactly how easy and accessible it is to build a custom API using AI, what manual chore in your own life are you going to automate next?